Welcome to part 5 of my vertical steam engine build. In this video, I'm going to finish up the pieces on the drawing number 4. Worked on a little bit of that last time, and I'm going to change up the format a little bit on this one. Rather than just showing machining and cutters moving back and forth at high speed, I'm going to try and explain some of the reasons I do things. Some of you may know that these engines are my design. I'm not an engineer. I just like steam engines or steam equipment, and I'll take ideas from various drawings, put my twist on them, and draw something up and machine it, put it together, and see if it works. So nothing is guaranteed to work. When we get to the end of this series, the engine may or may not run, and I'll let you know. You'll see it either succeed or fail, as may be. So we're going to start with the piston. I made some changes on the fly. The pistons I've made in the past for these engines, the piston rod has just been threaded into the piston. Well, this time I decided that I was going to step down the piston rod, tap it for a number 256 screw, or thread it for a number 256 screw, and then put a recess in the piston and hold it on with a nut against a shoulder. So, not sure how that's going to work. We'll get to the machine shop and see how this works, and hopefully you enjoy this change in format. Let me know in the comments if you do. This is the piston and the piston rod. The piston rod is made out of 1/8 inch drill rod, and turn down the step on the end of that about 1/4 inch down to tapping diameter for a number 256 nut. Get it measured in there. Take a couple more passes on that just to get it to the right diameter for the tap. Cut, then measure. Then we put the number 256 die in the die holder and run that on there for about 1/8 of an inch, maybe a little less. It doesn't need to be that long, just enough to hold the nut so the end of the rod is just at the end of the nut. Then we I'm going to try and put a nut on this and make sure everything is right. I have neuropathy in my fingers, so it's pretty hard sometimes to put a nut on these things, so I'll taper that down a bit and see if we can get the nut on there. If the nut threads on, then I'll be okay. And we finally got it. There it is. So then we move on to the piston. We've got the nut on there. Now we face off the piston. That's a piece of 1/2 inch round stock. I test fit it in the bore. It pulls out. If I've got my finger over the bore, it pulls out with a good pop. So I think it'll make a good piston. So we get that faced off, and then we after we do that, we've got to drill a hole. So I spot it, and just a little bit of a dimple in there, just so it'll catch the point of the drill bit, and then put the drill bit in and drill through The piston will be a 1/4 inch thick, so want to drill through at least a 1/4 inch, maybe a little bit more, and then we test fit the piston rod into that hole, and it works pretty good. It's not a real tight fit, but I think it'll work. So then we have to put a counterbore in there to take the nut and washer, which is 70 thousandths thick, together. So I put a 5/16 inch end mill in the drill chuck, which I know you're not supposed to put an end mill in a drill chuck, but for this, that'll counterbore that down to 70 thousandths. And so that should take the nut and the washer and not be above the face of the piston. Let me get that measured, make sure it's good, and I actually got it a little bit deeper than 70 thousandths. Then we part it off, and as I've mentioned before, I'm not real good at parting. I've worked on this. I turned my parting blade around, made sure I had a good edge on it, made sure it was straight. I think it was bent the last time I tried to part something with it. I'm parting this off just a little over a 1/4 of an inch. Plan on turning it around and putting it back into the collet chuck when I get done parting it off, and then facing the entire thing to length. So we'll get that parted off. It turns out I had my parting blade a little low, so I ended up breaking that off the end. Now I've got it turned around in the chuck, face it down so the entire depth is 1/4 inch. There was a line on the, it was marked up with a 1/4 inch line. The line is still there. I just face it down to the line, and there it is. That's the piston with the rod on it. Now we got to measure that to make sure it's the right length. The drawing calls for a total length from the end of the piston to be 1 3/4 inches. So I'll measure that with the caliper, calculate what I need to take off of it, and got just about 90 thousandths on there for. So now we put it back in, put the rod back in, run the facing tool on it, and get that taken care of down to the right dimension, the right length, and everything should be just fine when I get that done. We'll do the rest of that off camera. This is the crosshead guide. It goes between the piston rod and the main rod to help convert the reciprocating motion to rotary. Piece of 1/2 inch stock in the collet chuck, centering it with the centering indicator, and then we move on to facing off the top, which will be the bottom of the crosshead when it gets done. Just getting a nice smooth surface there, and after that we go to cutting the round stock down to a rectangular with round edges. To do this, touch off on the sides, move in 0.125 on each side, and that'll leave a 1/4 inch in the middle. And so we'll get one side done. taking small cuts so it doesn't deflect anything. Then we move to the other side, taking about 20 thousandths cuts, and just work that down so we get a 1/4 inch centered on the circle. Make sure that everything is good there. Take some nice easy cuts. Get the caliper out, measure it, make sure it's a 1/4 inch, and then we'll move on to the next stage, which I put a 1/8 inch end mill in the milling machine. I'm cutting a slot in the crosshead, 1/8 inch wide by a 1/4 inch deep. If it's a little wider than an 1/8 inch, that is not that much of a problem. Actually, we want clearance for the 1/8 inch wide main rod to go in there. So just move down, again, very light cuts, so I can not getting any deflection on the milling cutter, and working down just a little bit at a time till I get to a full 1/4 inch depth. The other end is a drilled and tapped hole for 540. That's where the piston rod will screw in. I'm just drilling that through, and then take that out, take the drill bit out after we've got a little over a 1/4 inch. Put the 540 tap in the tap follower and run that thread down. After that is threaded, put a little oil on there for cutting. After that hole is tapped, I'll then take the collet block out, turn it 90 degrees, because I have to drill a hole for the pin that holds the main rod into the crosshead. So that is going to be a number 256 thread on one side and a through hole on the other side. So I have the moving an 1/8 of an inch in from the end, which I got with a edge finder, drill through with a 256 tap drill all the way through. And then after that, I put a drill bit in for a 256 clearance drill and drill that through one side of the slot. And just watch very carefully so I don't go through both sides. And then take the number 256 tap, and using that clearance hole as a guide, just tap the other side. So when I get the pin made or use a 256 screw, whichever I decide to do, I'll try and make a pin, but we'll see how it works. Then I take the thing out. I cut it off with a hacksaw. I could have moved it over to the lathe and the collet chuck and parted it off, but I just cut it off thick long with a hacksaw, put it into the vise with parallel, and facing it to length. It's got to be, according to the drawing, 1/2 inch long. Well, just work down until we get it to a 1/2 inch, and then the crosshead will be done. This is the main rod. It connects the crosshead to the crank disc through the crank pin. and turns the reciprocating motion into rotary. I forgot to turn the camera on when I drilled the hole, but I'm sure you've all seen holes drilled before. So now we're reaming an 1/8 inch hole, and then change the drill bit to a number 41 for the one for the crankshaft for the crosshead. And this is the only real critical dimension on this piece. The centers of the holes have to be 2.0 inches apart. So I cranked the table over, and I decided I was going to narrow the 1/4 inch by 1/8 inch stock to 3/16, except for the big end. So now I'm milling down the sides of the rod. Since the rod is 1/8 inch thick, my 1/8 inch parallels wouldn't work, so I just used a steel rule for a parallel in there. So it isn't exactly parallel. It measures pretty accurately, but nothing like a parallel would. So get that cut down, turn it over, cut the other side down, and now I'm cutting it to length. As I said, the dimensions aren't critical. I want to make sure I have enough clearance in the crosshead so it doesn't bottom out, and of course you don't need it to go into the hole, because that would ruin the whole piece and we'd have to start all over. So just work the mill back and forth with 20 thousandths cuts. I've got a line drawn where I want to stop. I just stop when the line goes away, and we'll turn it over, and I'll do the same on the other end. And I've got it turned over. I'm milling down the big end. So the large part of the big end is supposed to be 1/4 inch according to the drawing. Again, I've just got a line drawn on the piece, and cut it off with the mill, and I'll take it over to the vise, round off the corners, round off the crosshead end with the file. I have all the pieces, the cylinder or the piston, the crosshead, and the main rod all put together, and I didn't think very clearly about how I'm going to assemble this thing, but I take the whole piston assembly off, put the piston rod on the crank, or the main rod, some of the screws I have are magnetic, some of them aren't, so piston put on. And there it is. It spins pretty good. There is no lubrication on this thing, so I got everything working pretty good. That'll end the video for this week, and we'll see next video. We'll do the valve assembly. We'll see how that goes. Until then, have a good week. Like, subscribe, and if there's something you can think of that would improve this, let me know that too. But thanks for watching.